Hi, I am Amy Lovell. I'm in the Department of Physics and Astronomy. I'm one of the professors of astronomy, and I've been at Agnes Scott as a faculty member for 21 years, and I was a Scottie myself for 4 years in the 80s, and I majored in physics and astronomy then. I'm talking to you from the Delafield Planetarium, which is in our wonderful Bradley Observatory on campus. This room is a planetarium which is used both for teaching purposes and for public outreach and visiting with the public. And the thing that you see above my head is a projector that has bulbs and lenses in it that produce a very realistic view of the sky and allows us a dark sky simulation even inside the light polluted city. In our department, we offer degrees in astrophysics, in physics, and in mathematics physics as a combined major. The astrophysics students take introductory astronomy, which is a course on the planets and the solar system and the physics of the universe. And then we have a course on stars and galaxies and cosmology, which is kind of like the origins of the universe. And we also have a laboratory course called Intermediate Astronomical Techniques, where students use telescopes that are in dark sites on remote mountains and also learn how to use this planetarium and how to make effective scientific presentations. And so the astronomy program, people take astronomy, they also take physics, and then they learn how to put them together. And in the physics major, people take physics courses. That would be things like forces and heat and motion, and then some of the more advanced topics like quantum physics and relativity. An Agnes Scott class is as individual as the person teaching it and as the person taking it. Most of the classes in physics and astronomy are pretty small at the upper level. An introductory class would include some lecture, some activities, some group work, some projects, some lab. There's a little bit of everything at the beginning level of the course. And then after that, at the upper level, some of the classes are project-based, some of them are lab-based, some of them are more hands-on, some of them are a little more theoretical. It's a little bit of everything, and it just kind of depends on the instructor's style and it depends on the topic at hand. One of the things we really like is to get our students involved in research as quickly as possible. We like to get students doing research even embedded within courses, even in the earlier courses if we possibly can. And like I said, that's one of the things we do in that sophomore level lab, even that some students take in their first year, is they start doing research projects on their own. And in the upper level classes, people would be doing research. Sophomore year, we like to really encourage people to do summer research if they can, definitely by junior year or rising into the senior year, trying to do some research off campus. It could be at NASA, it could be at another university, it could be at an observatory. Our students have done lots of different things, but research is really important. Even if somebody doesn't want to go into a research career, the problem solving and the strategizing and the intellectual development of research is really an important part of learning physics and astrophysics. The liberal arts college environment is a different way of learning physics. It's a different way of approaching scientific learning in general. So it's a very problem-solving and conceptual approach, a little more theoretical approach, because this is not a major research university and we don't have billion-dollar labs. So we take a lot of theoretical approaches. We do kind of case studies and projects and individual, like, guided learning experiences. And so it's a more collaborative way of learning. Agnes Scott's physics program is very collaborative. Our students work together really well. It's not a competitive environment. It's not one where somebody's elbowing somebody else out of the way. The students really work together a lot. So I like the liberal arts college and I like our departmental culture because the students really do support each other, and that's a very special thing. And then in terms of the women's college environment, it is a real privilege to be in a place where we can focus on people whose skills have not really been tapped in the sciences. Women, anybody with a marginalized identity, people of color, people who have an element of their identity that is in any way marginalized, we can really encourage and support and make sure that everybody is getting a leg up and getting the skills they need to succeed and to follow their intellectual passions. So it's a real gift to teach at a women's college and to be in a place where we can focus on, whose voices have been missing at the table of science. And I really love that. I think that's one of the things that's really special about Agnes Scott. after Agnes Scott, our students do all kinds of things. Like I can't just say, well, they all become research scientists, because they don't. It's very common for physics majors to double major with mathematics, and a lot of people go in the physics direction, some people go in the mathematics direction. Astrophysics is a place where people will double major or have a minor in another subject, and so those combinations can become really important. Our students are involved in research science. Our students get involved in education. We have a number of people out there teaching the next generations. We also have people working in nonprofits. We have people who have become really good programmers, and working with data is an important skill that they now apply to a completely different area that has nothing to do with physics. It might be financial analysis, it might be environmental analysis, but they're combining those kinds of things. And I mentioned the environment. There's a lot of people who are involved in environmental science and environmental studies and environmental advocacy. So people go in all kinds of directions. We have people in medicine. We have people who have gone into a variety of careers using some of the things that they got interested in during their major here, which may or may not be directly related to what they did here. We talked just a second ago about research, and I think getting involved in research as early as possible and not waiting until you've taken some number of upper level courses to get started in research is really helpful and really important. One of the things that we like students to do in our program is to focus on presentation skills and scientific communication. We get the students involved giving tours to school groups in this planetarium, helping to teach children about science and space. That really helps people learn how to understand and articulate what they know, as well as, presentation and scientific communication is a really important professional skill. So integrating that and thinking about how you can not just know what you know, but explain what you know, it's a really important part of solidifying learning, and we really try to get people involved in that. The third thing is our program really tries to connect what people know. As a liberal arts college, you're going to be taking courses in other subjects. You're going to take foreign languages. You're going to take social sciences. You're going to take humanities. You're going to take arts. And having a place where you can think about how those things come together. And the things you're learning in other classes might be important and might have bearing on what you're learning in physics and astrophysics. And that can be really missing in some places that have a more narrowly focused, more directed, less broad major. And I think those connections are things that really keep people going and keep people interested in what they're learning. The coolest thing in Bradley Observatory is the Scotties, because having really intellectually engaged and interested students makes this place what it is. A planetarium is just a room. Equipment is just equipment. A telescope is just a telescope. But when a student looks through a telescope and says wow or cool or nifty or pulls out their phone to snap a picture of what they're looking at and tweet it to their friends, this is when it becomes really vibrant and interesting.